Hi, this is Mrs. Myers, and this is our lesson 2.1, segments and bisectors. We are basically going to be expanding our vocabulary a little bit in geometry. We've learned about points, labeled with capital letters. We've learned about lines, which go on forever, labeled with points on the line. We've talked about rays, which are part of a line, just extend in one direction. So now we're going to be talking about part of a line that doesn't extend forever in either direction, and that's called a segment. Okay, so a segment, or sometimes called a line segment, looks like this. It has two endpoints. Named endpoints because they are the points on the ends. A segment is named by its endpoints. All of these things we learned before all had notation, specific notation. Lines we had a bar over with arrows on both sides. Rays we had a bar over with an arrow pointing to the right. Notation for a segment is just a bar with no arrows because it doesn't extend forever in either direction. You could name this segment BA. It does not matter which order it goes in, but that is the notation for the segment itself. Notice we're going to talk about, when we're talking about the length of a segment, the notation's a little different, but that's going to come in a little bit. Okay, so if you remember, we learned the angle addition postulate back when we were learning about angles. Here we're going to be talking about the segment addition postulate. So angle addition postulate, if you remember, when we had adjacent angles, this little angle plus this little angle equaled the whole angle. So if this was like 10 degrees, this one was 20 degrees, the whole thing would be 30 degrees. You're just adding up the parts that are right next to each other. So segment addition postulate works the exact same way. When you have a segment, let's say AB, and another part of a segment, say BC, right next to it, no space in between, then the length of this first segment plus the length of the second segment equals the length of the entire segment. So when we're talking about adding segments together, this is an equation. We're not talking about adding the actual segment, we're talking about adding the length of one segment plus the length of another segment. Notice there are no bars over the notation for AB plus BC equals AC. So when it's in an equation, the notation is different. There's no bar over the AB and the BC and the AC. So this chart here is comparing angle notation with segment notation. If you remember, we talked about the angles. Angle itself. When you're talking about the angle itself, like angle ABC or angle 1, right? That's just talking about the angle itself. If you said angle 1 is a right angle, or angle ABC and angle 1 are complementary, you're just talking about the angles. When you want to use the measure of angles in an equation, measure of angle A plus the measure of angle B, let's say, equals 180, right? Then we need that little m in front. So there was a different notation. We were talking about the measure, the actual measurement of the angle versus talking about just the angle in general. Segments, same way. The length or measure has no bar, so you're going to have like AB plus BC equals AC. No bars, but when you're talking about the segment itself, there's a bar over it. Okay, so both of everything in this column here is in equations. That's when we need the little m for the angles and no bar for the segments. All right, so how are we going to use the segment addition postulate? Pretty much the same way we used angle addition postulate. Solving for x, finding the missing length of a segment, etc. So in this first example, it's labeled here that AB is x plus 5 and BC is x. And they tell us if AC is 25, so that means A to C, the whole thing is 25. Just like we did before, the first thing you want to do in these situations is label your diagram. You want to make sure that you are labeling your diagrams when you have problems like this. So then we can sort of see the equation. Remember, it's AB plus BC equals AC. Well, AB is x plus 5, and BC is x, and AC is 25. So that means this part, x plus 5, plus this part, x, equals the whole thing, 25. Then we just solve for x. 2x plus 5 equals 25, 2x equals 20, and x is 10. Therefore, we could find the length of AB by just plugging it back in, substituting back in, right? So AB, we know is x plus 5, and now we know that x is 10, so that means AB is 15. Okay, here's another example. If EG is 59, what are EF and FG? This says it's 8x minus 14. This is 4x plus 1. They're telling us EG is 59. Again, label your diagram. That's 59. Okay, so write this equation, solve it, and then turn the video back on to check your answers. Okay, so this should be the equation you wrote. And when you solve the equation, you get x is 6. And then you plug back in to get EF and FG. Notice this piece right here, we've had this before. When you write an equation, how can you justify that equation? In the past, we've had like linear pair postulate, vertical angles theorem, etc. For this, our reason, our justification, and like if we wrote this kind of an equation in a proof, our reason would be what we just learned, the segment addition postulate. That's the reason. Okay, so bisectors. A bisector is basically to bisect something, means to cut something not just into two pieces, but into two actually exactly equal pieces or congruent pieces. So a bisector cuts an object into two congruent parts. It's really important to understand that it's congruent parts. You're cutting it right in half. Okay, so there's two types of bisectors. There's segment bisectors, where we divide a segment into two congruent segments. And if you look down a little bit, there's angle bisectors. Angle bisector divides an angle into two congruent angles. So those are two types of bisectors we're learning today. We'll start with the segment bisector. A segment bisector can actually be a point, a line, a ray, or a segment. So when you have a segment, to divide it in half, I could cut it in half by just putting a point right in the middle. I could cut it in half by putting a ray through it. I could cut it in half by putting a whole line through it. I could cut it in half just by putting another segment through it. So all of those ways are ways to cut a segment in half. It's not, they're all called segment bisectors. The one where you just put a point in the middle has a special name. That point right in the middle is called the midpoint. The point right in the middle is called the midpoint. Now, when I draw this, I drew this right here for you. Can you tell that's a midpoint? Well, it kind of looks sort of like it is, maybe not, I don't know, I didn't really measure it out. But we need some sort of notation on our diagram to show that we intend that to be a midpoint. So if you look here, this is how you mark segments congruent to each other. You can mark it with one tick mark and one tick mark. Here they use double, right? Just like we did with our angles, right? When we wanted to label two angles congruent, that angle is the same as that angle. So we matched the notation on the two angles to show that those two angles had the same exact measurement. We're going to do the same thing with these segments. Little tick marks are how we mark them congruent to each other. So whenever you draw a diagram and you intend it to be a midpoint or a bisector, you have to mark the diagram showing that you want these to be cut into two congruent pieces. Okay, so this is called a midpoint right here. This is a midpoint, this is a midpoint. When a segment is bisected, the two endpoints of the segment are said to be equidistant from the midpoint. So that's just another way to say they're the same distance from the center. Equidistant means equal distance. So you could say in this diagram here that they did, this diagram here, point B is equidistant from A and C. That's just a vocabulary word there. Okay, so how does this translate into solving equations and writing equations and solving for x? Well, here we have this segment. They tell us PQ is 6x minus 7 and QR is 5x plus 1, but different from how we did it before, where they told us what the whole length was and we used the segment addition postulate. Here they're not telling us the whole length. But they are telling us this really important piece of information. Q is the midpoint. Well, if Q is the midpoint, that means this length is the same as this length. So we're going to write an equation to reflect that they are the same length. 6x minus 7 equals 5x plus 1. Equals because the two segments are congruent, that makes their measures equal to each other. So what justifies me writing that equation? How do I know that they're equal to each other? This one is the definition of midpoint. So in a proof, or whenever you're asked the reason to justify that equation, it's because of this keyword that they told you that you knew how to write that equation. So when you solve this, subtract 5x from both sides, you get x, add 7 to both sides is 8. So x is 8. When we plug that back in for PQ, 6 times 8 minus 7, right, plugging that in here, you're going to get 41. And then you plug in 5 times 8 plus 1, you're going to get 41. And then for PR then, if this is 41 and this is 41, the whole thing is 41 plus 41, or 82. Okay, so angle bisectors, which some of you, we've talked about this before in class. An angle bisector divides an angle into two congruent angles. So let's just compare the difference, right? A segment bisector divides a segment into two congruent segments. Well, clearly when you split something in half, you have two halves of that thing. If you split a cookie in half, you have two halves of a cookie. If you split a segment in half, you have two segments that are the same. Here, if you split an angle in half, you're going to have two angles that are the same measure or congruent to each other. So this says ray AY is the angle bisector of angle. Well, the angle we're splitting in half is this one. So we're cutting angle XAZ in half. So AY, ray AY is the angle bisector of angle XAZ. So you can see they marked this angle congruent to this angle. Right? So this little angle and this little angle, you have to mark them congruent if you intend your drawing to depict an angle bisector. You have to make sure you mark those angles congruent. So example 4 here, AC bisects angle DAB. We have to draw our diagram. Angle DAB. Our ray is AC bisecting that angle. So I have to mark my two angles congruent. If the measured angle DAC is 58 degrees, well, DAC is D to A to C. That's this one is 58 degrees. what's the measure of angle DAB? So they're asking us to find this whole thing. Well, if it's a bisector, we know that these two angles are congruent, so this has to be 58 degrees as well. So the measure of angle DAB is just either 58 plus 58, or you can think of it as 2 times 58. Either way, we get 116 degrees for angle DAB. Okay, you've learned about perpendicular lines before. You might not have ever seen this symbol before, but that symbol means is perpendicular to. So perpendicular lines are lines that intersect to form right angles. Okay, so when you have two lines that intersect at right angles, we say one of the lines, say line CD, is perpendicular to line AB. So this is the way you would write that in geometry notation. And it doesn't matter which way you write it. CD perpendicular to AB, AB perpendicular to CD. Okay, it forms four right angles there if you have full lines. Perpendicular bisector then. So now we're kind of combining some vocabulary words. A bisector divides a object into two congruent pieces, right? Well, a segment bisector can go through the segment at any angle, right? This is a bisector. But there's a special type of bisector called a perpendicular bisector. If you straighten out this bisector, that's the bisector, right? If you straighten it up so that you make right angles like this, then it's called a perpendicular bisector. So this one term, you know, if I have a diagram and it says, you know, AB is the perpendicular bisector of CD, if that's a given statement, I want to make sure that I mark my diagram with, there's a lot of information to mark here. First of all, they're perpendicular, so we have right angles. And second of all, something's getting cut in half. Now, you have to be careful because it might say CD is bisecting AB. Well then, just this is congruent to that, right? Bisecting. If CD, oops, I forgot the D. If CD is bisecting AB, it means AB is getting cut in half. It doesn't mean CD is getting cut in half, just AB. So you have to watch the way it's worded there. Okay, so in conclusion then, we have a few things we've learned. Looking at diagrams and noticing, this was from before, right, how angles can be marked and how segments can be marked congruent. And now we have both of those things that we can do in a diagram. And since we have our vocabulary words of bisectors, in this diagram I see angles being bisected, and in this diagram I see segment being bisected. So this is going to be an example of an angle bisector. So what conclusions can we make? Well, we can conclude that angle 1 is congruent to angle 2 in that diagram. And so this ray is an angle bisector. Over here, we can conclude that TW is congruent to VW. You might also say that PQ bisects TV. That's another way of saying it. Okay, this is just a little exercise in recognizing angle pairs that you have learned about before. And here is a review of what you've learned before, but then also sketching a diagram that uses our new vocabulary word, angle bisector. This goes with this one. So why don't you try doing those and turn on the video again, pause it first, turn it on again when you're done. Okay, so this diagram is a little tricky, but you can see vertical angles in here, a couple of pairs. Here's a linear pair. There's lots of linear pairs around here. Okay, so I just gave a few examples in these answers. So this is going to be a little practice for you on the back here. I'm not going to go through all of this in the video, but just to get you started, in the left-hand column here, you're given some information, and it's kind of like practicing marking your diagrams if you were writing a proof or if you were solving for X, and they gave you some given information. So this says AC, segment AC, bisects angle DAB. So you want to first find angle DAB. So there's angle DAB. That's the angle that you want to cut into two congruent pieces. So when you mark your diagram, we're not talking about this tracing that I just did. That's actually not part of what they say what you want to do when you're marking your diagram. You want to just mark that AC bisects DAB. I would just mark this angle congruent to that angle. And then my conclusion would be angle DAC is congruent to angle BAC. That would be my conclusion from the markings in my diagram. So if you look at number 2, point G is the midpoint of FG. What you want to do is mark congruent segments. I'm not going to do it for you, but that's what we're looking for. We're looking for some congruent tick marks on some segments here. Okay, so the rest you should be able to figure out based on the given information. Actually, I'll pause this and put up the answers and you can check them. Okay, so just notice the markings on the diagram. That's really important. And like for this one, when there's perpendicular, I named one angle that's a right angle. There's actually 4 right angles you could name. Notice in this one, single tick mark for these two, double tick mark for these two, or vice versa, but you can't mark them all the same. And then remember that if you are given something parallel, you can look for all those 4 types of angles that we learned about. This one I named alternate interior angles that are congruent. Okay, thank you.